We are the Group C1, the collaboration of Section A and B, and we are tasked to present these three problems, which we will discuss as we go through this presentation. Here are the members of Group C1.
Good day, everyone. I am Amalito Xavier Jr. from SME Training.
Good day, everyone. I am Angelo Versosa from PCB 3A.
Good day, everyone. I am Ronan Fernandez Nyasi from PCB 3.
Good day, everyone. I am Mark Willie Casallas from PCB 3B.
Hello, everyone. I'm Messias Plaza from PCB 3A.
Good day, everyone. I am Jubel Perez from PSME 3.
Good day, everyone. I am Frichi Alcantara from BSME 3A.
Hi everyone, I am Impinado de Slimar, BSME 3B.
So, let's proceed to the problems.
So problem number 1. Find the width of the belt necessary to transmit 7.5 kilowatts to a pulley 300 millimeter diameter. If the pulley makes 1,600 RPM and the coefficient of friction between the belt and the pulley is 0.22. Assume the angle of contact as 210 degrees and the maximum tension in the belt is not to exceed 8 Newton per millimeter width. So these are the given. So we have hour, which is our P. So we have 7.5 kilowatt. So since the given is kilowatt and the unit of P is watts, so we need to convert kilowatt into watts. So we have 1 kilowatt is equivalent to 1,000 watts. This is equal to 7,500 watts. And also we have our diameter, which is our D, and we have 300 millimeter. So since the given is millimeter and the unit of diameter is meter, so we need to convert millimeter into meter. So we have 1 meter is equivalent to 1,000 millimeter is equals to 0.3 meter. And we have our radius, we have 150 millimeter. Again, we need to convert millimeter into meter. So we have 1 meter is equivalent to 1,000 millimeter is equals to 0.15 millimeter. And also we have our speed, which is our N. We have 1,600 RPM. And also we have our coefficient, which is 0.22. And also for our angle, we have 210 degrees. So in order to convert degrees into rad, we need to multiply by pi over 180. So we have 3.665 rad. And also we have our tension, which is 8 Newton per millimeter. So for our required, we need to find our width of the belt. And for the solution, first we need to find our velocity. So for our velocity, our formula would be V, or velocity, is equals to pi times diameter, our D, times speed, or our N, over 60 seconds. So substitute the value. So we have pi 0.3 meter times 1,600 RPM over 60 seconds. So we have our velocity, which is 25.13 meter per second. And for the ratio of driving tension, the formula will be used to be tension 1, or T1, over tension 2, or T2 is equals to E raised to the power of our coefficient times our angle. So we have substitute the value. So we have T1 over T2 is equals to E raised to the power of 0.22 times 3.665. So we have 2.2396 as our equation. So for the following solution, we discussed by Mr. Messias Borlas.
Solution. After we get the velocity and the ratio of driving tension, next we have to get the power transmitted, which is the formula is P equals open parenthesis T sub 1 minus T sub 2 close parenthesis times V or velocity. Then after that, we have to substitute the value of each equation. So P equals 7,500 watts equals, copy the T sub 1 minus T sub 2 times the value of the velocity, which is 25.13 meter per second. So after that, we have to transpose the or we have to multiply the both sides, which is to cancel the 25.13 meter per second. So T sub 1 minus T sub 2 is equals to 298.45 Newton. And after that, we have to transpose the T sub 2, and T sub 1 is equals to 298.45 Newton. And change the palito negative T sub 2 is the equation 2. Then we have to substitute the equation 2 to equation 1. So we have to use the T sub 1 minus over T sub 2 is equals to 2.2396. And we have to T sub 1 is equals to 298.45 Newton plus T sub 2 over T sub 2 is equals to 2.2396. Then after we compute that in the calculator, then the value of T sub 2 is equals to 240.76 Newton. Then since we don't have the value of T sub 1, so we have to substitute the T sub 2 to either equation 1 or equation 2. So T sub 1 is equals to 298.45 Newton plus T sub 2. Then T sub 1 is equals to simply to have to substitute the value of the T sub 2. So 298.45 Newton plus 240.76 Newton. Then T sub 1 is equals to 539.21 Newton. Then after that, we have the value of T sub 1, so we have to solve the width of the belt. So the formula is B equals to T sub 1 over T, or the maximum tension. So B is equals to we have to substitute the value of T sub 1, which is 539.51 Newton, over the maximum tension, which is given 8 Newton over millimeter. So, and the final answer is B equals 67.4 millimeter.
Problem number 2.
That's all.
A flat belt is required to transmit 35 kilowatts from a pulley of 1.5 effective diameter running at 300 r.p.m. The angle of contact speed over 11 over 24 of the circumference and the coefficient of friction between belt and pulley surface is 0.3. Determine taking centrifugal tension into account, width of the belt is required. It is given that the belt thickness is 9.5 mm. Density of its materials is 1.1 megagram per cubic meter, and the related permissible working stress is 2.5 MPa or megapascal. Next is these are the given. P is equal to 35 kilowatts, so we need to convert it to watts by multiplying it by 1000 watts over 1 kilowatt equals to 35 times 10 to the power of 3, or 35,000 watts. D is equal to 1.5 meter. N is equals to 300 r.p.m. Angle is equals to 11 over 24 in the given. To convert the rad, we must multiply by 2 pi equals 2.8797 rad. Coefficient is equals to 0.3. Thickness of the belt is equals to 9.5 millimeters
convert it to meter by multiplying it by 1 meter over 1000 meter equals 0.0095 meter. Stress of the rod 2.5 MPa or 2.5 times 10 to the power of 6 Newton over meter squared. The last one is the density 1.1 megagrams per cubic meter. Since in megagrams per cubic meter, we need to convert into kilogram per cubic meter by multiplied by 1000 kilogram per cubic meter over 1 megagram per cubic meter. So equals 1100 kilogram per cubic meter. Required width of the belt in millimeter. I'm done with my part. To continue the discussion is Mr. Ronan Miasik.
Thank you, Mr. Casallas. So now in part of the solution. So find first the velocity, cross-section area, P and mass of the belt. So first is the velocity. Velocity, the formula of the velocity is V equals pi multiplied by diameter multiplied by speed over 60. So pi equals 1.5 meter multiplied by 300 rpm over 60 seconds. Using the calculator, the answer equals V equals 23.56 meter per second. Second is the cross-section area. A equals BT, where B equals width and T equals tension. A equals B multiplied by 9.5 millimeter times 0.001 meter over 1 millimeter. So millimeter is cancelled, then the value of A equals B multiplied by 0.0095 meters squared. So next is the max tension of the tight side. T equals stress multiplied by area. So T equals 2.5 times 10 to the power of 6 Newton per meter squared multiplied by B times 0.0095 meters squared. So the answer is T equals 23,750 with Newton. So third is the mass. M equals area times length times density. M equals 0.0095 meters squared, which is the area, times 1 the length and times the density, which is 1,100 kilogram per meter. And the answer is mass equals 10.45 kilogram per meter. So now let's find the TC, T1 and T2 and the width. Now let's find the TC, T1 and T2 and the width. Centrifugal tension. TC equals mass multiplied by velocity squared. And we substitute the formula. TC equals 10.45 weight kilogram over meter multiplied by 23.56 meter over second squared. So the answer is TC equals 5,800.519 with Newton. So that's all. Thank you. And the following solutions is discussed by Miss Alcantara.
So thank you, Mr. Miyasi. To continue, since we already have the value for tension and the centrifugal tension, so we can now compute the tension in tight side or the T1. So the formula for T1 is T1 is equals to T minus Tc. Then substitute the values. So T1 is equals to 23750 B and minus 5808 0.519 N. So our T1 is equals to 17,949.48 N. And since we already have our value for T1, we also need the value for T2. And we need to use the formula for the ratio of driving tension, which is T1 over T2 is equals to E raised to coefficient times angle. So substitute the value for T1. 17,949.48 B over T2 is equals to E raised to 0.3 times 2.877. So compute, then we can get 17,949.48 B over T2 equals to 2.374. So our equation 1, or the value for the T2, is equals to 17,949.48 B over 2.3724. And since we already have our equation 1, we can use the formula of the power transmitted to get the equation 2. The formula is P equals T1 minus T2 times the velocity. And since we already have the value for the power, which is 3,500 watts, substitute the values. 3,500 watts is equals to 17,949.48 B minus T2 times the velocity, which is 23.56 meter per second. So our equation 2 is 3,500 watts is equals to 17,949.48 B minus T2 times 23.56 meter per second. Then substitute equation 1 to equation 2. So 3,500 watts is equals to 17,949.48 B minus 17,949.48 B over 2.3724 times the velocity, which is 23.56 meter per second. So our B, or the width, is 0.14307 meter. And since our width needs to be in millimeter, we need to convert meter to millimeter. So we need to multiply our width to 1000 mm over 1 m. So our B is equals to 14307 millimeter or 143 mm. That's all for the problem.
A roof drive transmits 75 kilowatt through a 1.5 meter diameter, 45 degrees groove pulley rotating at 200 rpm. The coefficient of friction between the ropes and the pulley grooves is 0.3, and the angle of lap is 160 degrees. Each roof has a mass of 0.6 kg per meter and can safely take a pull of 800 N. Taking centrifugal tension into account, determine first the number of ropes required for the drive. Second, initial rope tension. Given P is equals to 75 kilowatt. 75 kilowatt is converted into watt. So 1000 watt over 1 kilowatt. T is equals to 1.5 meter. 2 beta is equals to 45 degrees. 2 beta, i-divide na to siya. 2 is equals to, the value of B is 45 degrees over 2. I-divide na to siya of 2 para makancel ang 2 beta. So ang nabili ng beta na lang is 22.5. N is equals to 200 rpm. Coefficient 0.3. 160 degrees times pi over 180 degrees equals to, our rod is 2.7925. Mass is equals to 0.6 kg per millimeter. T is equals to 800 N. Required number of ropes. Initial tension. So, solution. Find first the velocity. The formula of velocity, V is equals to pi dn over 60 equals pi. So, substitute na to ang value sa D, which is 1.5 meter. Then, substitute na to value sa N. So, N is equals to 200 rpm. So, muna siya over 60. So, our velocity equals 15.708.
Okay, thank you, Mr. Mire. And now let's proceed on getting the ratio of driving tension. So the formula of getting the ratio of driving tension is T sub 1 over T sub 2 equals E raised to the power of coefficient times the angle 1 over sine beta. So basically, you just really substitute the given values. So we have here T sub 1 over T sub 2 equals 8.9276. So after getting the ratio of driving tension, let's proceed on getting the centrifugal tension. So the reason why we get first the velocity because this is where we're going to apply it. So the formula of centrifugal tension is Tc equals m by the mass times the square of velocity. So 0.6 kilogram per meters times 15. The square of 15.70 millimeter per second. So we come up here 148.0448 Newton. So after getting the centrifugal tension, let's proceed on getting the tension inside of the belt. The formula is T1 equals T minus Tc. So T1 equals 800 Newton minus 148.0448 Newton. So we have T1 equals 651.9552 Newton. So since we already have the T1, let's proceed on getting the T2. So we just need to equate the two equations. We have here T sub 1 over T2 equals 8.9276 rather. So just substitute the given values. We have here 651.9552 over T2 equals 8.9276. So if you have with you your calculators, you just use the shift solve process. We have here T2 equals 70.0269 Newton. Thank you, and that will
Thank
be
you,
all.
Mr. Isidro. So for the continuation of the discussion of problem number 3, I am going to solve and discuss the power transmitted. So power transmitted formula would be tension 1 minus tension 2 multiplied by the velocity. Since tension 1 is already given and or solved, and tension 2 and also the velocity, so substitute the value. So power transmitted is equal to 651.9552 Newton minus 73.0269 Newton multiplied by the velocity, which is 15.7080 meter per second. So we can so the answer would be 9,993.8057 watts. So to get the number of ropes, so the total power over the power per belt, since the total power is 7,500 watts over the power per belt, which is 9,993.8057 watts. So our number of ropes would be 8.24. Since we are talking about the belts, we can round it off to a whole number, which is the number of ropes will be 9 belts. And lastly, the initial tension. So the formula of the initial tension would be tension 1 plus tension 2 plus 2 centrifugal tension over 2. Since the 2 can be cancelled out, so the remaining would be the tension 1 plus tension 2 over 2 plus the centrifugal tension. So substitute the value 651.9552 Newton plus 73.0269 Newton over 2 plus the centrifugal tension would be 148.0448 Newton. So we can now add all. So our initial tension would be 510.5 Newton. So that will be all of my discussion in problem number 3. Thank you.
I just want to give you some important pointers for you to solve the problem. The first one is you really need to familiarize the conversion or the dimensional analysis, especially the units. The second one is you need to analyze the problem and understand thoroughly for you to know what values you need to input to the formula. And lastly, practice makes perfect. So you just need to practice and practice solving the solution in order for you to comprehend or to know how to analyze a problem, especially in this topic, ropes and belts. That's all, and thank you for watching.